You guys dah familiarized slides 49 until 79? Okay. Alright. So now saya try untuk share screen sebelum ya. Sebentar lagi seorang masuk. Kita tunggu lagi seorang masuk. Okay, saya share kejap ya. Nampak ke skrin saya?
Nampak Doktor.
Nampak tu.
Okay. Tu boleh masukkan. Lepas tu nama betul lah. Nama penuh tapi nama singkatan untuk you lah. Okay, we were supposed to have 61 students. Baru 57. So lagi 4. 56 dah pula. Ada yang termasuk terkeluar ke? Saya tunggu lagi 1 minit je lah. If not, we will just start, okay? Okay, so I think that we can start now. Okay, everyone ready? Ready ke?
Yes, Doktor.
Yes Doktor.
Alright, good, good. Okay, saya start sekarang ya. 1, 2, 3. So what is the difference between molarity and molality? You have 30 seconds. Alright, so 16 students menjawab biru. So the difference between molarity and molality, okay, so basically molality is moles of solutes. Ingat mole bahagi kilogram solution. Kalau molarity, molarity apa? Mole bahagi liter of solution. Dia perbezaan dekat solution tu. Okay? Alright. So kita go to the next question. Alright, so Sharv, the highest one. Okay? Alright, so kita pergi next question ya. True or false? Part per billion ppb is milligram of solutes per liter of solution. Okay, jawapannya adalah salah. Alright. Okay, saya go the next one first. Okay, Hassan Zhao pula yang naik sekarang. Alright. So, next question. True or false lagi? Part per million is microgram of solutes per liter of solution. Betul ke? Is it true or false? Alright, jawapannya adalah false ya. So, part per million is milligram. Part per is microgram. Okay, that's the difference. Per million and part per billion. Right. So, siapa tempat pertama? Sesin tempat pertama. Okay. So, next question. Another quiz. Okay, what is the molality? Molality. When 0.6 gram of KCl was dissolved in 0.5 kilogram of distilled water. Molality. Cepat jawab ni. Senang je calculation ni. Okay, so the correct answer is 0.0161. Okay, so 38 of you got it right. So basically, when we do molality kan tadi kita tengok apa formula adalah mole over kilogram of solvent. So mole in terms of here adalah 0.6 divided by the molar mass 74.55 gram, and then you got the answer of mole divided by 0.5 kilogram of distilled water. Right? So you got 0.016. Alright. Siapa yang paling pantas? Arif. Alright, that's good. Okay, so next question. Another is the molarity by dissolving 8 gram of sodium hydroxide in water so that the final volume is 250 mil. Okay, 15 seconds left. Berapakah molarity sodium hydroxide jika final volume 250 mil? Alright, so 46 of you got it right. Yes, 0.8. Okay, so basically sama sahaja. 8 gram divided by grams per mole, you got number of mole, and then you divided it by 250 mil, but it needs to be in liter, so 0.25 liter. Okay, right. So the fastest one. Okay, so next question. What is the weight percent of a solution of 6 gram salicylic acid in 100 grams of solution? Okay. Did you guys get the answer? Pay attention towards the unit here. Alright, so 52 of you got it right. So 6 divided by 100, alright? And then times 100, so basically 6%, and weight per weight because both of them is in gram. Okay. Alright, so next question. True or false? ppm is equal to microgram per gram equal to milligram per kilo. Betul ke? Alright, so it's true, 41. Okay, alright, so next, 1 ppb equal to 1 nanogram per gram equal to 1 nanogram per mil equal to 1 microgram per liter. Is it true? All right, so it's true, yeah? Okay, good job. Okay, the next question, I think is the last question. Okay, this is a quiz. What is the volume needed to prepare 2.5 liter of 0.36 sodium hydrox? Sorry, starting with concentrated acid that is 18 molar. This is a question of M1, V1, M2, V2. Okay, 30 seconds left. Right. So 39 of you got it right. It's about 50 mil. Okay, so this is about M1, V1, M2. All right. So who stands in the podium? Number 3, Gan. Good job. Number 2, Azrin. Good job. And number 1, Banu. All right, good job, everyone. Okay, so from the first place until the third place, alright, you guys boleh tuntut hadiah saya. Saya screenshot ni so that I didn't forget your name. Okay, so I should screenshot. Alright, whenever the campus nanti ataupun bila-bila boleh tuntut hadiah dengan saya. Alright, so basically saya tak perlu dah go through sangat for this kind of apa exercises untuk I mean that for the calculation section lah, because as I said that it is much more better kalau you guys dapat buat exercises. Okay, so in terms of that, based on this, I think that most of you, however there are some of you maybe tak familiar lagi, never mind, I will try to give some exercises later on. Okay, for you to brush up on your calculation, because this calculation is very important. It is the foundation of everything lah, apa yang kita akan belajar selepas ini. Alright, so shall we continue to the new chapter? So basically we have finished the first chapter, okay? So okay ke nak continue next chapter kedua? Alright. Okay, so continue chapter. Okay, can you see my screen? The slides? Nampak ya? Okay. Alright. So basically, before this, for chapter 1, you have learned on apa kita dah belajar tentang how you buat sampling. And then bila you dah buat sampling, you need to store it. What kind of procedures have you done in terms of storing it? And then in terms of after that, kita preserve kan, macam mana kita preserve, guna apa nitric acid ke ataupun kita freeze dia ke kan. Alright, so the next one, so all of this kita buat prior analysis lah. Okay, starting from this chapter, you are going to look at on the analysis part. Analysis part sahaja. Maksudnya analisis terhadap analytes ataupun compound of interest yang you dah sample daripada atas tadi. Okay, so contohnya kalau sebelum ni you sample oil, okay, what kind of analysis yang sepatutnya kita buat. Tapi kalau you nak sample, you nak try to identify heavy metal, so what kind of analysis should we done? Okay, so selepas ini memang kita fokus kepada analysis part. Kita nak tahu the principles and how are we going to do it, how are we going to prepare the samples for analysis. Okay, so this is chapter 1 lah. Yang ni chapter 1 yang kita dah belajar before this. So chapter 2 until I think chapter, if I'm not mistaken, towards the end lah. Towards the end sampai chapter 8 ke chapter 9 tah? Sorry, ke chapter 11, 12, something like that lah. Saya pun dah lupa. Tetapi after this, from chapter 2 towards the end, so all of that is for your analysis. Dah tak ada dah sampling, store, preserve ni. Kita dah terus kepada analysis part. Okay. So, alright. So who killed Napoleon actually? Or what should we say? What killed Napoleon? Okay. It is said that Napoleon ataupun yang kita suggested that Napoleon had suffered and died from arsenic poisoning. Kita kata dia mati disebabkan arsenic poisoning. So how can we know arsenic was the reason? Okay, arsenic metals kan. So in this when okay, kalau kita ada kat depan Napoleon, kita ni adalah chemist ataupun the forensic specialist. Apa yang kita ambil sampel, apa kita ambil untuk tahu poisoning. So blood sample. So blood sample kita nak preserve macam mana, kita nak nak store macam mana. So all of those things kita dapat daripada chapter 1. But now we want to continue the journey kita tu untuk kita betul-betul nak sure sama ada arsenik ke punca kematian Napoleon. Okay. Another example, you have a water sample containing methylene blue, which is a dye. What should you do to know how much methylene blue was in the water? Methylene blue. So basically sekarang methylene blue ni you dapat dalam sample water you dah sampling, you dah preserve, you dah store, and then how are you going to know how much? So this is in terms of how much ni apa? Quantitative. Okay, methylene blue is in the water. Okay, container waste. Okay, ni dekat Antarctica. Okay, container waste yang telah dilupuskan di Antarctica. How can we know heavy metals leached from the container secara tidak langsung contaminate the ice? So kan ini kan barrel yang diperbuat daripada metals juga. So macam ni kita nak tahu these metals yang sini ni dia leach ke dalam ice ini. Okay, so alright, so yang ini tak apa, there's a lot of contoh-contoh lah, but I think that you get the idea of the next chapter lah, chapter ini yang mana kita nak continue our journey tu selepas kita sampling untuk kita tahu sama ada betul ke compound of interest kita tu available ke dekat dalam kita punya sample. Okay, so now analysis of organic or inorganic analytes. So now kita tengok on the spectroscopic based methods. Okay, this is important. Kita dalam ni ada dua, waktu mula-mula saya explain kita ada 4. Kita ada spectroscopy based methods, kita ada chromatography based method, and then we have gravimetric, and then we have volumetric. So now we are going to look at spectroscopy based methods. Okay, in terms of spectroscopy based methods, first of all you need to know what is spectroscopy. Introduction of spectroscopy. Okay, so basically what is spectroscopy? Spectroscopy is that we want to analyze the property of the matter ni when it's with electromagnetic radiation. So when there is a question ataupun persoalan atau orang tanya, what is spectroscopy? What is spectroscopy? Spectroscopy ni adalah interaction of matter with electromagnetic radiation. Okay, so when we talk about spectroscopy, you terus terfikir tentang interaction matter itself kepada electromagnetic radiation. Okay, so now you dapat gambaran bahawa spektroskopi tu adalah apa interaksi di antara matter ataupun kita panggil macam compound of interest kita, the electromagnetic radiation yang diberikan. Okay, there are two important keywords here, which is interaction of matter dengan electromagnetic radiation. Okay, please remember this, okay? Because this is important. Okay, so spectroscopy, as I said, the study of properties of matter through its interaction with different frequency components of the electromagnetic radiation. Okay, you guys ada belajar electromagnetic radiation kan before this? Maksudnya in your engineering subject, ada belajar tak?
Ada sikit betul.
Ada sikit. Okay, alright. So electromagnetic radiation ni, kalau kita tengok through this spectrum yang dalam gambar ni, spectrum ni, okay. So this spectrum, it shows that the electromagnetic radiation on its range. Okay, so for example, kalau gamma rays berada di hujung yang mana frequency is high. Okay, and then we move towards X-ray yang mana yang you selalu pergi X-ray kalau untuk medical check-up ke apa ke, X-ray, dia punya frequency lagi rendah daripada gamma ray. Okay, and then we go to UV, ultraviolet radiation, and then the visible light. So basically, visible light yang ada cahaya sekarang yang kita ada ni, itu pun kita panggil sebagai electromagnetic radiation, tetapi dia berada di range visible light, where we can see that the range may be around, the frequency is around 10 to the power of 14 until 10 to the power of 16. So, when we talk about sunlight pun, it is a electromagnetic radiation juga. Okay? Radiation berada di bawah, and then microwaves, radio waves, and then yang paling rendah sekali adalah low frequency, extremely low frequency, ELF. Okay? So selalu ini yang berada dekat pencawang-pencawang lah. Okay, so all of this mengeluarkan electromagnetic radiation, atau apa kita panggil radiation lah, kita keluarkan radiation. Radiation dalam bentuk frekuensi. Okay. Right. Okay ke saya kat situ? Faham tak maksud electromagnetic radiation? Means that how can we get electromagnetic radiation? Your cell phones also mengeluarkan electromagnetic radiation. Tetapi it is harmless lah, because the frequency tu is very low. Kalau you nak banding dengan X-ray, gamma ray yang frequency it is very high. Okay? Right. So, why spectroscopy? Kenapa kita sibuk lah nak belajar in terms of spectroscopy? Kenapa we want to know on the interaction of matter dengan electromagnetic radiation ni? Because spectroscopy is a technique used for detection. Kita nak detect. Tadi kan macam kita punya logic, daripada awal kita dah sample, kita dah preserve, kita dah store. Takkanlah kita nak stop sampai situ. We want to know whether Napoleon ni betul-betul mati disebabkan oleh asli. So it is a technique to use for detection, as well as kalau nanti bila kita further, kita boleh go for determination for quantitative purposes. Okay. Alright. So, what is a spectrum in analytical chemistry? Okay, tadi kita belajar what is spectroscopy. Sekarang what is a spectrum? Spectrum ni adalah data that we have obtained from a spectrometer ataupun spectroscopic analysis. Okay, basically something like this. You have a sample. You go to, for example, UV visible instrument, and then dapat something like this. This is a data lah. Okay, so this data we call, okay, so spectrum is a data that we obtain from a spectrometer. So spectrometer ni adalah this UV vis instrument, and then the spectrum ni plot dia is intensity of energy detected versus the wavelength. Okay, so intensity versus wavelength. Wavelength yang mana, okay, contoh ni kita detect, wavelength 425 meter paling intense. So sebab tu dia tinggi. So when we talk about a spectrum, spectrum adalah plot of intensity of energy detected versus the wavelength of the energy. Okay. So this is examples of spectrum. Kalau you tengok, this is ultraviolet spectroscopy. So kalau kita boleh tengok, kalau kita go down, kita tengok the highest intensity is at 400 nanometer. This is in infrared spectroscopy. Spectroscopy, kalau you tengok, nanti kita akan tengok lah yang tajam-tajam ni apa benda maksud dia, whether it's good or not. Okay, this is NMR, nuclear magnetic spectroscopy. Yang ni saya rasa kita tak cover dalam syllabus you, and mass spectrometry pun kita tak cover. Kita only cover I think UV vis je kot, ultraviolet spectroscopy. Okay, so basically that is a spectrum. Alright, so electromagnetic radiation ni yang kita duk cerita tadi, the cell phone, sunlight, even sunlight pun electromagnetic radiation. Kalau nak tengok, kalau you nak senang faham, okay, sunlight diperlukan oleh pokok kan untuk photosynthesis. So the sunlight bila dia hit the pokok, bila dia hit the chloroplast, what happened to the chloroplast? So the interaction is actually is a spectroscopy lah. Maksudnya interaction, so, this is like an analogy lah. Okay, jangan guna contoh tu pula. So interaction between chloroplast and the sunlight, because it is still an electromagnetic radiation. So what happens? We want to study those interaction lah, tetapi in this case kita study dalam instrument yang kita nak nak analyze kita punya sample. Alright, so electromagnetic radiation is a form of energy whose behavior is described by the properties of both waves and particles. Okay, maybe lebih faham dari segi sini. Okay, so tadi kita tengok in terms of electromagnetic radiation, kita tengok dia punya waves kan, dia punya dia punya wave number and wavelength. Alright, so it shows that the wave properties of electromagnetic radiation, dia ada waves. It flows in a waves punya pattern. Okay, it flows in a wave punya pattern, so that's why we call a wavelength. So from top here to top here we call wavelength. Okay, so optical properties are explained by this as waves. Interaction between radiation and matter are described by treating light as a particle. Okay, in terms of explanation on waves ni, nanti saya akan saya ada satu video yang mana nanti saya akan letak dekat e-learning for you to have a better understanding on the wave properties of an electromagnetic radiation. Okay, alright, so wavelength and frequencies of the electromagnetic radiation. Tadi wave tu lah, wave yang kita duduk tengok tadi tu. So wavelength tu tadi kan I've shown you that the wave distance of one cycle. So from the top here to the top here is one cycle. So we call one wavelength. Okay. Alright, frequency is a number of cycles passing a fixed point per unit. Okay. So wavelength punya formula is wavelength equivalent to C is the speed of light divided by V. V is frequency. Okay. So if we want to know on the wavelength, it is speed of light divided by frequency, and then we can rearrange it to get the frequency to speed of light divided by the wavelength. So this is just another formula for you to be able to calculate later on lah. Alright, so electromagnetic radiation consists of quantum energy that during the interaction with molecules, the energy waves behave like a particle, as what I have mentioned before. So energy equal to HV. H ni adalah Planck constant. Planck constant, and then V adalah tadi itulah frekuensi tadi. Photon is the E equal to Hc over V. Over wavelength. So EHV ni kan, EHV. So V ni kita frekuensi ni kan kita boleh expand, equivalent to E equal to H C over wavelength. The one kita tengok sini tadi, this one. So the lower the wavelength, the higher the energy. Okay ke?
Okay, Doktor.
Okay. Alright. So in terms of calculations dan juga explanation tu, as I said that nanti saya akan letak ada satu video yang menerangkan lebih lebih detail lagi tentang itu. Alright. So inilah sama yang saya tengok in terms of what is electromagnetic radiation and di mana setiap range itu berlaku. Okay. Alright. So now kita nak go into the instrumentation part of it. Okay. So for example, saya bagi contoh, I give you an example of UV visible. Okay. So this red thing adalah you punya sample yang mana kita letak di dalam instrument tu. So the incident light ni in this case kita akan ambil incident light yang dari UV visible punya range. Kalau kita tengok kat sini, kita ambil di sinilah area di sini. Area 500 nanometer. Yang mana incident light in UV vis range itu akan beam akan dipancarkan kepada you punya sample, and sample you ni akan absorb the electromagnetic radiation, tetapi bila dia absorb, dia tak nak dia kena keluarkan balik. So that's why kita ada in terms of transmitted here dan scattered. Saya rasa yang ni kita akan lebih faham nanti bila kita tengok dari segi what happens for the interaction of the incident light and your sample, and then what transmitted and what has been scattered. But in a nutshell, this is what happens in your instrument. The instrument will provide an electric radiation, tak kisahlah in terms of UV visible range ke, in terms of infrared range ke, tak kisah. Tetapi bila share kepada sample you ni akan absorb. Kadang-kadang absorb, kadang-kadang di emit. So nanti tak apa, yang itu tu kita tengok later on, tetapi the principle is that your your electromagnetic radiation ni akan something to the sample, and then the sample tu pula akan transmit ataupun scatter the light to show their physical things. Ada some sample dia akan scatter. So itu dia punya karakteristik dia. And then kita boleh calculate nanti, berapa banyak dia scatter, berapa banyak dia absorb, berapa banyak dia transmit. So all of this is important to untuk calculate later on what is the characteristic of our sample. Okay. Faham tak?
Sorry, faham. Tapi
Lagging ke
suara
suara saya?
Delta lagging sikit.
Oh, okay. Tak apa. So, alright. So, basic kita macam apa yang saya explain tadi, bila kita tengok on the internet, kita ada, nanti akan ada adsorption, ada apa? Emission, akan ada scattering. Light tu nanti, bila dia masuk kepada sampel you, akan do apa yang terjadi kepada light tu tiga benda, which is absorption ke, emission ke, scattering ke. So all of this akan kita boleh apa identify what happens to the sample. Okay. So what is absorption, what is emission, what is scattering? So ini adalah interaction of matter with your electromagnetic radiation. Supply electromagnetic radiation, your sample might be able to absorb, or it might be able to emit, or it might scatter the light. Right. So absorption ni kita basically sama apa yang absorption ni adalah take up, kita serap. Emission, to give off, kita keluarkan. Scattering tu adalah kita reflect, redirection of light to its interact, kita redirect the light. Sekarang basically we want to know on the definition of each of the interactions. Okay, so first of all, absorption. Absorption ni adalah a transition. Okay, sekarang ni kalau you boleh faham in terms of saya tunjuk dari segi gambar rajah lah macam ni. Okay, absorption. Absorption tu berlaku apabila, so sample you, kejap, suara saya masih lag ke? Alright, sometimes. Dah okay eh? Okay. Alright, so basically, whenever that, kalau sample you tu belum di hit with electromagnetic radiation, it will be at the ground state. Ground state ni kalau kita panggil macam ni lah, dia state normal. Dia macam kalau kita duduk apa? Duduk saja, kita our ground state. Kita tak ada apa-apa kepada diri kita untuk become excited ke, untuk become depressed ke, something like that. So your sample pun sama, when it is in a normal state, kita panggil dia ground state. Tetapi when your sample, katakanlah saya letak dalam bentuk dot ya, so your sample, bila saya bagi electromagnetic radiation, bila saya bagi electromagnetic radiation kepada dia, it has a choice whether to absorb ke, to emit ke, ataupun to scatter. Okay, scatter. So, kalau kita kata di absorb, absorb ni, so sekarang ni you duduk macam tu saja. Okay, you duduk, tapi bila tiba-tiba your parents give you food. So, you will become excited. You will become, your energy, bila setelah you makan, your energy akan naik. So that is what happens to your sample as well. When we supply with electromagnetic radiation, if it decides to absorb, then it will jump into the next energy level, yang mana kita panggil sebagai excited state. Okay, dia jump kepada next energy level. Tetapi this excited state, it is a state yang tidak stable, yang mana, okay, contohnya lepas you makan, you dah duduk kat excited state, tetapi selepas tu another 4 to 5 hours you will become lapar, itu tak? So you will go down back to your original state, which is the ground state. So when it absorb, it becomes excited state. Tetapi when from excited state, after a few moments, it will go back down to the ground state, and this going down from excited to ground state, it will emit. Sebab energi kan dia tidak boleh dimusnahkan. Dia hanya boleh di-preserve. Saya tak tahu, saya tak berapa sure betul ke, is it dynamics ke energy ni? Energy cannot be absorbed. It is being preserved ke, something like that kot.
Cannot
Cannot
be
be
created or
destroyed.
destroyed.
Cannot be created and destroyed, but it can be preserved
Can be transferred
something like that
or
lah.
something like that.
Transferred
Yes.
ataupun the preserve. So basically, it is the same. So when we apply energy towards your sample, it will become excited. Tetapi excited tu hanyalah sementara sahaja. So it will be going back down to its ground state, but energy yang telah diabsorb tadi, it will emit it back lah. Maksudnya dikeluarkan balik. Sebab dia tak boleh, energy tu kan tidak boleh duduk dalam diri dia sahaja, dia kena keluarkan balik energy tu. So, this is called emission. Kalau naik tu kita absorption, kalau turun ni emission. So, sebenarnya kalau absorption ni senang kalau kita nak distinguish between absorption dengan emission ni. Okay, macam mana kita nak distinguish? Distinguish tu adalah kita nak tengok the original state of your sample. Kalau absorption, original state dia adalah ground state. Then it becomes an excited state. Tetapi kalau emission, original dia mesti daripada excited state. And going back down to the... So that is how, katakanlah ada soalan, how we differentiate between absorption and emission. So that's how you answer. Absorption tu, the original state of the sample is at ground state and becomes excited, while emission daripada excited going back down to the ground state. Okay. Setakat sini faham tak in terms of absorption and emission?
Faham.
Faham ya? So basically, based on punya nation tadi in figurative form, tengok balik in terms of kalau ayat lah. So a transition, excitation, okay, from a lower state level to a higher state with the transfer of energy from radiation field. For example, flame ke ataupun light ke to an absorber. In this case, our sample atoms of a metal. So sama saja kalau kalau kita tengok ni, absorption ni adalah transition daripada lower state energy level kepada a higher state energy. So daripada normal ground state kepada excited state. Tetapi emission, a transition ataupun kita panggil relaxation. Relaxation ni, okay, kita dah excited kan? Okay, relax. So bila kita relax, we are going back down to the ground state. So a relaxation from a higher state energy level to a lower level with a transfer of energy from the emitter to the radiation field. So now kita keluarkan balik radiation itu kepada nanti for it to be calculated lah. Okay. Scattering ni macam mana? Scattering ni simply dia reflect lah, maksudnya your sample tu dia tak absorb. Bila tak ada absorption, maksudnya tidaklah berlaku emission, betul? So dia tak absorb pun, dia scatter je. Tapi scattering ni dia pergi dia pergi at a lot of direction lah. So katakanlah you punya sample here, so you give your energy electromagnetic radiation, it is neither absorb ataupun emit, tetapi dia scatter. So scatter tu di mana? Dia scatter you punya energy tu. So this scattering ni pun kita boleh kira. Oh, okay. What is the characteristics of the scattering? Okay. Alright. Okay. So tadi we talk about transition. Transition ni simply put, transition ni macam tadi lah, daripada ground state kepada excited state ataupun daripada ground state kepada excited itu kita panggil excitation. Daripada excited state kepada ground state kita panggil relaxation. Okay, so this possible track of transition data ke bawah, dalam kita punya instrument ni kita ada banyak kind of transition. So for ultraviolet, it is an electronic transition. Kalau infrared, it is a vibration. Infrared pun ada yang vibrational ataupun rotational lah. So basically kita ada electronic, vibrational ataupun rotational. Okay. So kalau saya nak gambaran of how macam nak membezakan antara elektronik dan juga vibrational ataupun rotational. Okay. Based on this daripada gambar rajah inilah. So we will see that okay, electronic transition berlaku daripada E2 kepada E1. It is quite a big jump. Di dalam setiap energy level ada dia punya rotational and vibrational punya transition. Di dalam di dalam level dia sendiri pun dia ada dan juga rotational level. Faham? Electronic transition dan juga rotational and vibrational level means that daripada sini you boleh buat gambaran bahawa elektronik ni dia from one elektronik step yang lain itu kepada E1, tetapi dalam setiap EE ni dia ada dia punya step tersendiri yang mana step itu adalah rotational ataupun vibrational punya level. Okay, bahawa energi diperlukan untuk excite an electronic transition adalah lagi besar daripada energi yang diperlukan untuk excitekan for rotational or vibrational punya level. Because rotational and vibrational punya level dia tak perlukan energi sebab dia is within the transition. Tetapi for an electronic transition, it needs from one electronic transition to another electronic transition, it needs a much more higher energy as shown here. Okay, setakat sini faham tak tentang elektron dan juga
Doctor.
rotational and vibrational?
Doctor.
Faham ya?
Doctor, I have
Oh,
one question.
yeah,
Doctor
sure.
you say that vibrational and rotational transition tu it doesn't need energy kan? Energy tu
No,
dia sebab tadi putus so macam
okay. Okay, sekarang ni, okay. All of those transition needs energy to apa orang kata tu untuk become excited. Semua memang memerlukan energy to become excited. Tetapi energy, how much is energy is needed? So in terms of for electronic transition, it needs much more energy as compared to rotational and vibrational punya transition, because rotational and vibrational punya transition is in within di dalam you put one electronic transition ni. So that jump is not that big. So it does not need a much more higher energy level lah as compared to electronic transition.
okay, faham Doctor.
Faham ya? Okay. Untuk lagi faham, mungkin saya boleh nyatakan macam ni lah. Okay. Tadi kan kita tengok kat sini mana okay. So ultraviolet ya.
And the slide before, can you explain it in English? Okay.
Slide
The
before
slide- No, the one with the E1 and E2.
is it this one?
Yes.
Okay. So maybe I can just okay, let me explain it again, okay? Alright, let me ask first, Faisal, apa ni, international student?
Yes.
Oh, okay, alright. Sorry, because before this, I've asked that maybe there is no international student, so that's why I mixed my lectures. But now I can just straight away use English for my lectures. Okay?
So thank you, Doctor.
All right. Okay. So, for this illustration, in terms of energy changes, okay, let me go back to this one first. Okay, it says that for ultraviolet, so this is all of this is your electromagnetic radiation. Okay, electromagnetic radiation. So, when we looked at this picture, okay, when we look at this picture, the visible light where corresponds to the ultraviolet visible instrument, the energy here, we shall see this this form. Energy here, it is around 2.48 electron volts. Okay, but when we looked at infrared or microwaves or radio waves, it is much more lower than the visible light. So, from this perspective, we can understand this much more better. Okay, so when we looked at ultraviolet, as I said that ultraviolet, it is around 2.48 electron volts. But for rotational or vibrational, for transition, it is about 0.124. Okay. So for IR, it is 0.24 electron volts. Okay. So based on that, so it shows that for UV, it can achieve electronic transition because the energy is about 2.48 electron volts. But for IR, for infrared, it can only achieve rotational and vibrational transition because the energy is about 0.124 electron volts. So that's why I would say I said that to have an electronic transition from from ground state to a higher state, for example, in this illustration is from E2 to E1, you would need a higher energy as compared to the energy needed for a rotational and vibrational transition based on this diagram, because the energy needed for a visible is quite high as compared to the infrared or microwaves or maybe radio waves is much more lower energy. Did I answer your question?
Yeah, I understand.
Okay.
Thank you.
So in that case, maybe so basically when we want to explain about for electronic transition, I straight away say that okay, for electronic energy needed rotational and vibrational transition. So you give an example. Electronic transition is from ultraviolet electromagnetic radiation. But for rotational and vibrational transition, it is from infrared, microwaves, or maybe radio waves electromagnetic radiation because the energy is very low. So it can only achieve rotational or vibrational. Okay. Do you have any question? Ada soalan ke? No question, yeah? Okay, all right. Okay, if my voice is lagging, you can just straight away open your mic and then terus cakap, yeah? Okay. These are the types of spectroscopy. Okay, these are the types of another transition lah. Okay, so for gamma emission, it is a nuclear transition. It interacts with your nucleus inside the apa? Inside your atoms, inside your molecules. So this gamma emission, because it is in very high energy, so it interacts nuclearly. Okay, so we mainly for these subjects, we are more focusing on the electron transition and vibrational transition lah. Okay, right. So examples of spectroscopic methods, as I said, we have absorption, emission, and scattering. But for your syllabus, it is just about emission and absorption. Okay, so if we were to look at absorption, it is a UV visible instrumentation, maybe NMR or ESR, but we will not be covering that. It's just a UV visible. And then for emission, when we want to look at emission, we will look at emission spectroscopy of a UV visible as well. Okay. Scattering, we have a Raman spectroscopy, but all of this we are not focusing into with your syllabus. Okay. All right. Okay. So based on that, we are going to in depth on what is atomic spectroscopy, what is molecular spectroscopy, and then we will be looking at absorption till later on. Okay, can we have a 5-minute? Is it possible to have a 5 minutes break?
Sure, Doctor.
Okay. Okay, all right. So we will resume at 12:40 lah. Okay, kejap je, 12:40. Okay. All right. Thank you, everyone. Okay, I think that we can start now. Okay, so before that, do you guys have any question? Any question? Yes, slides.
So far, no, Doctor.
So far, no, yeah. Okay. Some of your friends have asked me in terms of for next week is as I said that next week we will have your first quiz on week 3 lah. So because this week is week 2, so week 3. Okay. I want to ask whether you guys nak buat quiz dalam whether you guys want to do the quiz in your lecture hours or you guys much more comfortable to do it after office hours, lecture hour. Orang lain? Anyone else?
I prefer lecture hour, Doctor.
Lecture. Okay, in that case, uh, the quiz on next Friday, next Thursday, sorry, next Thursday during lecture. But if that's the case, then I might need to, in the future lah, and I might have in class as well because if all of the quizzes and tests will be conducted lecture hour, then I will need time to make up on your lectures, okay? Because your quizzes is going to be about half an hour. So half an hour, four quizzes is about 2 hours. And then test is going to be about 1.5 hour. So guys, about 3.5 hours lah we have been missing on our lectures. So I will do a replacement lecture or an additional asynchronous lecture lah. I will just record it and then I will just put it on e-learning for you guys to ni. Okay, some of you in terms of how many questions I don't know yet because I have not created the questions yet. Okay, so it will just be from the beginning, chapter 1, until what we have learned next Sunday. Okay, so we will the quizzes towards the end of the class on Thursday lah. All right. Okay. If there is no questions, I may just continue with this because we have more minutes left. Okay. So, yeah.
Lecture. Next Thursday is
Yeah.
Deepavali. Next
Thursday is Deepavali eh. Oh,
4/11.
okay. Okay, kejap. Saya try tengok. Okay. Next Thursday 4th of tu kan? Okay. Tak apalah. Apa tu? Next Thursday week 3, 4. Okay. Kalau for next Thursday, I mean that if it is just for quiz 1, possible tak if we do it on the if that's the case, then maybe we can just do it on next Sunday, 31st. Possible ke? Okay, so we will do
Yeah, sure.
on 31st next Sunday, but it's just towards the end of half an hour end of the session lah. Okay, so basically if that's the case, then the content of the quiz will just be until this Thursday je lah. The content of the quiz, yeah. Okay. Is there any more question? Ada ke? No. Okay. Alright.
Doktor,
So
quiz apa
yes.
tadi? Our quiz punya,
Apa?
our quiz title consists of chapter 1, chapter 2
Chapter 1 and chapter 2 lah until because chapter 2 we will finish it on this Thursday. The quiz will just be chapter 1 and chapter 2 because next week, that next Sunday, I will continue on chapter 3. And towards the end of the session on Sunday tu, half an hour tu, we will have the first quiz lah. But the quiz will just be on chapter 1 and chapter 2.
Okay.
Okay?
Thank you, Doctor.
Okay. Alright, so maybe if I can finish these two slides, last two slides. Okay, so atomic spectroscopy is the measurement of a wavelength ataupun intensity that is emitted or absorbed by free atoms. So it goes with the name lah, atomic spectroscopy. When we want to analyze atoms, we use atomic spectroscopy. But the first thing, your sample must be converted to atoms. Example spectroscopy, we have atomic fluorescence spectroscopy, atomic adsorption spectroscopy, and atomic emission spectroscopy. So basically, in all of these three instruments of atomic spectroscopy, the instrument has been designed for your sample. Usually sample kita letak in a liquid form. So liquid sample will be converted into atoms right before it has been targeted with your electromagnetic radiation for atomic spectroscopy lah. Okay, for molecular spectroscopy, the examination of interaction of light with molecules. Okay, with the molecules, not atoms. Atoms satu sahaja, it is just one atom. If there is a lot of atoms, it calls molecules. So molecules can absorb light, emit light, and scatter light. So for this kind of molecular spectroscopy, it is for ultravisible, infrared, and maybe NMR. Okay, can you see the atomic spectroscopy and molecular spectroscopy? Both of it is the same, but for atomic spectroscopy, your sample need to be atomized, needs to be changed into an atom punya configuration. For molecules, it is just molecules. Because we after this we will go into what is atomic spectroscopy and what is molecular spectroscopy. Okay. Okay. The difference between atomic and molecular spectroscopy. Okay. All right. So I think now it's 12:50 already. So do you have any questions or any other questions lah regarding the quiz lagi ke ataupun apa-apalah? Do you have any other questions? No, yeah. Okay. So okay. You guys all you guys ada hutang I satu benda. Which is the date for your assignment. So because last week I told you I would need those dates. Which week would you be comfortable to submit your assignment 1 and assignment 2? So right after this, you just inside the WhatsApp group so that everyone can know on which week have you decided to submit your assignment 1 and assignment 2. Okay, so that's the first thing. The second thing that for Lecture 2, I've posted on e-learning and that you need to do, which will be counted. So please do so. For that submission, I've opened for 1 week. Next Friday, next. Right. So somebody asked Kahoot tak masuk carry mark kan? No. Kahoot, it doesn't masuk carry mark. Tetapi I think that it is good for me to know where are you guys at in terms of whether my lectures are clear or not, whether you can catch up with the syllabus or not. Okay, it's just for me to know, and it is good for you as well to get the calculations out of the way. When you have understand the calculations, then you don't need to reading and doing the exercises. Okay, all right. So that's all. If we don't have, I
Doktor,
think that's all. Yeah.
Doktor. Doktor kata
Yeah.
nak date untuk submission assignment tapi soalan assignmentnya belum keluar lagi kan?
Memang belum keluar lagi.
Oh, so Doktor
It
mau
is just that
just date.
I want the date so that when I know the date, I can tailor your submission assignment questions according to the date lah. Kalau you submit the buat soalan yang susah, macam tu. But as I said that it is advisable to do it to submit within week 13 or week 14 lah. But I give you ruang untuk you guys decide because I know that you have a lot of submission. So I give you peluang to decide dekat mana. Okay, so put it inside the WhatsApp group so that everyone can know. Maybe you can have a poll. Siapa yang setuju week 13, siapa setuju week 14. Something like that. So
Okay,
that
thank
this
you
week as
Doktor.
well, I can put assignment questions for you guys to look at, and then you can just start to do the assignment. Okay. Any more questions? Okay, tak ada. Alright. Thank you, everyone. Thank you for your time. Okay. I shall see you on next Thursday.
Thank you Doktor.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
So,